or phase diagrams are going to show us what phase or state a substance is in under different pressures or temperatures. So it's almost always a line going up and then splitting into two more lines. And they're going to separate into, we have gas, liquid, and solid. And here I've got pressure on my y-axis, so pressure is increasing as I move up. And here temperature is increasing as I move over. And the states make sense because at your highest temperature, you're most likely to have gas. You're most likely to excite the particles until they turn into a gas, they fly away from each other. At your lowest temperatures, you're most likely to have a solid. So you can even look at that and try to figure out. Solids and liquids have similar density. So when pressure increases, you push the particles closer together, you compress them, so you're more likely to have a solid or a liquid. At the higher pressure, you're more likely to have a gas at lower pressure. So sometimes you're given an unlabeled phase diagram and you have to figure out, do I have solid, do I have liquid, do I have gas? So the changes are whenever we're along one of these lines, we're at an equilibrium. So both exist. If I'm right here, I would have, or if I'm right along this line, I have an equilibrium between solid and liquid. So maybe when you have ice floating in your ice water, there's an equilibrium there, especially if you actually have it at 0 degrees, and so the ice isn't melting and melting and melting. So this is when you have both solid and liquid. Here's when you have both liquid and gas in equilibrium. And here's going to be solid and gas. As you travel from solid to liquid, you're melting your liquid. So know that solid to liquid is going to be melting. If you go from liquid to solid, you're freezing your substance. If you go from liquid to gas, crossing the equilibrium barrier like that, then you have vaporization. If you go from gas to liquid, then you have condensation. And these are probably the two words that are new for us. If you take a solid and turn it into a gas, it's subliming. A lot of people have seen dry ice on Halloween. Dry ice is subliming. If you have a gas that is turning into a solid, you have deposition. Right here, you have the equilibrium between solid, liquid, and gas. This is called the triple point. And if we get all the way up to here, this is the critical point. At critical point, you can't really tell the difference between a gas or a liquid. You have such high temperature, because you're all the way down here. Particles are moving really, really fast. But it's high pressure, so they're compressed together. So from the critical point on, you see my line stops. It's kind of like, well, this is gas, this is a liquid. This, it's kind of both. You know, it has the density of a liquid, but the viscosity of a gas, moving really fast. So let's go ahead and say what each of these are, because you have to be able to name each of these things. Okay, so vaporization, that's going to be when you have a liquid that turns into a gas, turns into a vapor. Condensation is when your gas turns into a liquid, like the mirror in your bathroom when you take a hot shower. All the gaseous water vapor hits the mirror and cools down, turns to a liquid. Melting, that's if a solid turns to a liquid. Freezing is if you have a liquid, it turns into a solid. We're good with that. These guys are the new ones. Sublimation is when a solid turns into a gas. And deposition is when a gas turns into a solid. Okay. Let's see. In triple point, that's when you have the equilibrium. Equilibrium of solid, liquid, and gas all together. The normal freezing point is going to be when you freeze, go from liquid to solid at 1 atmosphere. So if this was labeled as 1 atmosphere was here, then the normal freezing point would be right here, right? Because liquid turns into solid right here at this temperature. So this temperature would be my temperature of my normal freezing point. Okay? So normal just means at 1 atmosphere. So liquid to solid at 1 atmosphere. And normal boiling point, that's going to be liquid to gas at 1 atmosphere. Okay. So here's a diagram. It's not labeled for us. And let's see, I've got pressure on this side in atmospheres, temperature on this side in Kelvin, and we're going to do some problems on that. It says label the states. The first thing I'm going to do is label the states. I don't remember what was on the first slide, so I can't remember where does solid go, where does liquid go, where does gas go. But I do know if I have really high temperatures, I'm most likely to have, more likely to have a gas. And I know if I compress something, I'm more likely to make it a liquid or a solid. So that means liquids and solids are up here, right? And at a higher temperature, it would be a liquid, right? So these are my dense things. This is a dense thing at a high temperature. This must be the liquid. This is my dense thing at a low temperature. Must be a solid. And if I have low pressure, particles are floating around freely. This must be my gas. Okay. First problem done. Let's see. Part A. What state exists at 2 atmospheres and 200 Kelvin? These are typical problems you could get about these, and just getting familiar with the phase diagram. So 2 atmospheres and 200 Kelvin, that'll be point A. So it's 2 atmospheres and 200 Kelvin. 200 is right here. 2 atmospheres is right here. So this is my point A. And I know point B, I put it 300 Kelvin and also 2 atmospheres. So there's B. Okay. Next one. What state? Oh, what state exists at each of these? Well, I saw that this was in the liquid range and this was in the gas range, right? I heated up the liquid until I turned it to a vapor, to a gas. Okay, what happens as conditions change from point A to point B? Okay, if I go from a liquid to a gas, that's vaporization. And if I go from point B to point A, I'm going from a gas to a liquid, so that's condensation. Alright, and then we'll look at C to D and D to C. So, by the way, this was crossing over the liquid-gas barrier, so vaporization, condensation, C to D and D to C. So, C to D, I'm going from gas to solid. Gas to solid is deposition. I'm depositing a solid. D to C, it means I'm turning from a solid to a gas, so sublimation. So D to C was sublimation, right here. Sublimation as it turned from a solid to a gas, and deposition as it turned from a gas to a solid. So last one, I have D to A and A to D. So let's see, here's D, there's A, so I'm actually going to travel up, right? So I'm going to go from the solid to the liquid in D to A, and I'm going to go from liquid to solid as I go A to D. So D to A, I have a solid turning to a liquid, I have melting. So D to A, melting. Opposite of melting, I'm going to go from liquid to solid, so I have freezing. Okay, so that would be how we would label different transitions on the phase diagram. Some more questions we could get. What are the conditions? So what's the temperature and the pressure at the triple point? And what about the critical point? So triple point is where we have that solid, liquid, and gas. Right there, where they all three meet. And so that's going to be at, let's see, I've got 170 Kelvin and 1.4 atmospheres. 170 Kelvin and 1.4 ATM. So just looking for the temperature and pressure where all three exist. That's my triple point. And for the critical point, that's where I can't tell the difference between the gas and the liquid anymore because they're moving so fast, they're so hot, and the pressure's so high it's holding the particles together. So that ends up at 260 Kelvin for whatever substance this is, and it's going to be 2.2 atmospheres. So I just said for whatever substance this is, it's because every substance is going to have its own freezing points, its own melting points. It's going to have its own phase diagram. Let's see, and I think I said 260, I think. So you're always going to have different diagrams for every substance. Let's see, and then the next one I have, is the substance more dense as a solid or as a liquid? Let's look. Okay, so pressure is increasing as I go up, Yeah, it was 260. Pressure is increasing as I go up this way. When pressure is really, really high, you're going to compact particles more and more and more. So you're going to get to the most compact state you can get to as pressure is squeezing it together, right? So what I could do is I could say, here's solid and here's liquid. If I pick one temperature and go straight up, I can see gas turns to liquid as it's becoming more condensed or more dense, right? And it goes from liquid to solid as I increase the pressure even more. So this substance is going to be its most dense as a solid. If this line were slanted this way, which it could be, the line could be over here, it is for water. That would mean as I would go from a gas to a solid. If I squeeze even more, that solid would turn into a liquid. And liquid would be the most dense form of water, which is why ice skating works. As you push down on the ice a little bit of water, you're melting a little bit of the ice and then you kind of slide on that water. So for this one, we said solid. And it was because the slant of the line, you were more likely to have a solid at the highest pressure. The normal boiling point and the normal melting point, so let's see where it boils at 1 atmosphere. So here's 1 atmosphere, and whoops, this guy is lacking. Let's see, my other one was melting. This guy lacks it. This one doesn't have normal. It's not going to go through a liquid change. So let's say if this were at 1 atmosphere, what you would do is you'd read over and you would say, okay, here would be my solid to liquid change, so that would be the melting, and here would be my boiling as I go from liquid to gas. But this one lacks a normal melting point and then boiling point. And anything else? Nope, that's it. So you want to be able to read a phase diagram, be able to label the states. You need to know the vocabulary. So you need to know what all of these are. You need to know triple points, the normal points, critical points. And probably the trickiest question is figuring out if a substance is more dense as a solid or if it's more dense as a liquid. That's probably the trickiest part. Maybe constructing a phase diagram given the triple point and a couple of other points, but that would be it.